This isn't working. Oh, I got it to write a file, right? If I do this, go finder. I start the, and I think if I go to desktop, there's a dog PNG, but it has 0 bytes. Kotlin writing. Oh. Dude, it feels like image IO write is like not doing anything, right? Uh, I think I have comments in here, right? Hide. Right, it's okay. Writes an image using an arbitrary image writer. The informal name. Oh. Wait, what? Name of the format. So does this need to just be PNG? Let's see. Oh. Nice. It's interesting that it's way bigger, right? Okay. Let's just check it. And I gotta blow my nose. Oh, okay. That means the first test passed, so we're making progress. Can't read input file. Ah. Um. So what was the requirement here? It's probably like ah. So and it wants it to go back to task, right? Is there any reason this wouldn't go back to task? I think both of these are just me trying to figure stuff out. Check this again. There it is. Nice. Cool. Hiding information in such a way no one would ever guess there's a secret message hidden right before their eyes. The method we're going to use for concealing a message in an image is based on slight color changes that can't be detected. As you already know, the message data can be inserted at the position of the least significant bits of each color value of each pixel. That makes 3 bits per pixel and a total of 3. Okay, of course. There's no need to use them all. It would be more efficient to have an algorithm that picks which bits to use. We could make it even more complex. The bit selection can be based on a password so that the configuration is different every time. However, to keep things simple in this project, we will only use least significant bits of the blue color of each pixel. Thus, each image can hold up to image width times image heights bits. As seen in the previous stage, images can be handled as two-dimensional arrays. The image to hide the Okay, So each pixel has a byte that we can use. So input file, and then it's so now we can do, well, here before we even create val total bytes possible equals input image dot height times input image dot width, right? If right? I think that works. I've updated the strings too. So now okay, so this changes a little bit because it's like we have message byte array, right? And basically so like what does byte array look like actually? I want to see this. So what I'm thinking of doing is like what I'm thinking is like you have one more index, you plus plus each time, and then you that's not what I was expecting. Wasn't there? Try this. like we can keep almost everything, right? Because this just walks the image. And right now, what we're doing is indiscriminately setting them all to 1. But like, what if we only wanted to set the blue one, right? So this would only ever set the blue one to 1, but that's not actually what we want. We want it to be set to 1 or 0 based on the bytes in the hidden message, right? I'm a little confused, actually. They told me something here. Oh. We have to first convert it to an array of bytes. You can do it with encode to byte array. Let's just see what this looks like now, if it changed. It's the same. Respectively, an array of bytes can be restored to the string type. When the program reads the image bits in order to reconstruct the image, it has to know when to stop. That is, when it has read the entire message. For this, certain bytes should be applied at the end of the byte array. Specifically, we will add 3 bytes with values 003. When the program encounters these bytes, it will know that it has reached the end of the message. Hex to bytes. What? Didn't I just do this yesterday? Come on. Hex to binary. Okay. So can I not add one? Okay. Let's figure this out in a second. See, I don't think this is working. Doesn't it need to be like... what did they say here? Each bit of the bytes array will be saved at the position of the least significant. That's what I'm not understanding. It's like... Yeah, convert bytes to binary. How do I convert bytes to binary? What? Like, how... Kotlin. Like, why? Okay. 2 binary string. I don't know what integer is. What? I don't know. I don't understand. When is this written? Fucking 2012. Okay, I've done this before. I've totally done this before. Let's see. Open link in tab. No. Catalog. Fucking shit. How do I see the fucking projects, dude? Like, without changing. It's fucking people, dude. I swear to God. Open. I don't know where the... Let's see. Was it the Chuck Norris one? Yeah. Let's see how good a code I wrote. Get as binary. And here's an int. And now what is it using? Decimal. Okay, so I need these two. Oh, what we'll do is this. And then literally rip this into here. Wow, this is pretty hilarious actually. And then to byte array dot map. Well, hold on. If I'm going to create a new one anyway, let's make it the right length. And then val, so bytes. Let's just do .2 byte array. And then val bits equals bytes. No, let's do mutable list of string. Can I don't need to set the size. And now bytes dot for each. Let's just do string, and we do get actually, can I just do this, right? It's for each required byte how do I reconcile this? Oh, this is supposed to be no, it's bytes. Fuck. Okay, it's bytes that for each fuck. Byte versus int. So byte versus int, the difference was the size, right? And bytes are smaller than ints, so I should be able to cast this actually, right? You can't cast down, but you can cast up. Byte int. Get as binary byte. Oh. And then I actually need bits dot add. Okay. Cast byte. Okay. That works, sure. Okay. So now byte, so for each byte, and then we add one more, bits dot add ox 000003, right? And now let's see. Okay, I think this will be better. Oops. Oh, boom. And now we need to, let's see, 1, 2, 3, 4, 5, 6, 7. It did say, I saw that hint, right? It said we need to prepend. How much time do I got? 7 minutes? Okay, we can get a little bit more done. I don't know if I'll finish. 1, 2, 3, 4, 5, 6, 7, 8, right? So So right now my get is binary function returns in. I remember the pattern. It was like, okay, so what I'm gonna do here is like bits.add get as binary. Okay, so let's do this. Let's get a little bit more room, and maybe here we'll do val result equals this val, and then val stringy result, just whatever, result dot toString but we need like what happens now, right? So let's change this to string. So what happens now? I think it's gonna break it, right? Like I'm not gonna get the binary. Let's see. We can only hope, but I think it might try and interpret it. Interpret? Is this the right word? Convert it. No, it's okay. Oh wait, that's message. Fuck, am I printing the wrong thing? No, that's bits. Okay, so the bits. Let's just change that. Okay, so now I have the right thing. So the thing I need to do here is pad start the length. Okay, so val padding equals result. No. Okay, so I need the stringy result. And then val full byte in bits equals missing bits. I don't like the name of this, but stringy result dot length, and then it's 8 minus. Okay, so now full bit representation equals stringy result dot pad start with the missing bits, comma, 0. Oh, I see. And then you do full bit representation. Now this one, I get it literally 3. But actually, what I can do is this. I can do that. This can be hard-coded. Okay, let's test this real quick, and we'll be one step closer. So we need to hide cat, dog, hello world. Interesting. 1, 2, 3, 4. 1, 2, 3. What? Desired length of string. So I don't have to do any calculation, it seems like. Okay, try one more time. Hide. Come on, let's get this part done. Probably have like 1 minute left. Boom. Amazing how much time. 2 minutes. I don't think I'll have enough time, but what I need to do now is this isn't quite what I want, right? I know I'm getting the bits correct, but what I need to do, it's so funny I pulled this. So this is adding the full bit representation, but what I need is probably, here. Instead of bits.add, we need bits equals bar. Oh, okay, if I do this, then if I do it like this, no, let's not do that. Bits plus bit representation dot split. But then I'm gonna have those stupid starting and ending things. Oh my god. Like I have to do 2 mutable. There it is. Split dot drop last one dot drop 1. Okay, let's just check this. Let's finish that error check, right? So now we should be one step closer. We should get, and then bits, actually plus equals, let's see, dot split, actually No, let's just do, instead of all this, let's just do, 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 1. Okay, so now we restart it. Hide. Let's see if this works. Hello world. Phenomenal. Okay, and now finally, oh, and now this should work, right? If bits.size, so if there's too many bits, we can't hide it. And it ends with 1, 1. Okay, cool. That was pretty decent. We'll probably finish that next time. Merry Christmas.